Okay, how are you, everybody who is watching this video? I would like to take this opportunity to welcome all physical and online students into this interesting moments of learning electronics engineering. My name is Olenjolai, and I would like to take this opportunity to welcome you. We are going to have a very interesting module that's called instrumentation and measurements. We are in chapter 2 that's called electronics measurements and testing instruments. So we are serious and very committed. We ask you to have a fresh mindset. Take your exercise book, take your pen. We are not going to have some kinds of drawing. We just need a pen, fresh mind, and exercise book. We are heading to lecture 2 that's called electrical and electronics measuring instruments. I have some physical electrical engineering students at Dar es Salaam Institute of Technology, and also concerning all combining with some students who are not physical with us. So it's a very interesting lecture. We ask you to participate actively and ask you questions in case you have 1 or 2 or 3 questions. How are you, electrical engineering students? How are you, electrical engineering students? Well, you are fine. Thank you. That if you're fine, I'm also fine. And I have a very special package for you today. Are you ready for lecture 2? Okay, so let us test if you are ready by just having a quick review. Quick review of what you have learned in lecture 1. So, what was the title of the lecture? Title. Kanji. Title of the lecture. You forgot. Yohari. Title of the lecture. Electrical instruments. Emmanuel. Title of the lecture. Emmanuel is not there. Electronics measuring instruments. So the title of the lecture was electronics measuring instruments. And then we defined what is electronics measuring instruments. We say that these are the instruments. These are the what? Instruments that are used to measure and test the electrical physical quantity. Electrical physical what? Quantity. So define the terminology first of all. Then I gave you 17 examples of electronics and electrical measuring instruments. Then I left number 18, number 19, number 20, something like that. Did I give you 16, 16 or 16, right? 16 examples. 16 examples of electrical and the electronics measuring instruments. The first one is called what? Multimeter. Say multimeter. Say multimeter. Then the second one is called what? Power supply. The third one is called what? Function or signal generator. The first one is called what? A oscilloscope. Oscilloscope. Then number 5 is called what? A LCR what? Meter. Number 6 is called what? Spectrum analyzer. Number 7 is called what? Signal analyzer. Number 8 is called what? Frequency counter. Number 9 is called what? A functional generator. No, we have mentioned functional signal generator. Pardon? A clamp meter. Number 10 is called what? Pardon? Thermometer. Number 11 is called what? Voltage tester. Number 12 is called what? Bridge circuit. Number 13 is called what? Pardon? A? Pardon? Insulation? Megi Ohu meter. Megi Ohu meter, right? We say this is the most Emmanuel's favorite measuring instrument. Number 14, electrical load. Number 15, digital logic analyzer. Number 16, counter timer. Number 16 is counter timer. Number 17, voltimeter. Phase meter. Number 18, pardon? Energy meter. Very good. Energy meter, aka look meter in Tanzania. Number 19, wattimeter. Say wattimeter. Number 20, Emmanuel, number 20, you are searching them now. Number 20, madam? Voltimeter. No, we say voltimeter, you find in multimeter. Yavan? Pardon? Heavy? Ground resistance tester. Okay, ground resistance tester. Ground resistance tester. This is number 20. Then we discuss the number what? Number 1, this isn't it? And the number 2, number 3, number 4. Today we say that we are going to discuss the next special electrical measuring instrument. So let us start with number 5. That is called the LCR meter. Say LCR meter. L standing for what? Inductance. Then C standing for what? Capacitance. R standing for what? Resistance. So LCR meter, according to its name, we say that is the electrical, this is the electrical measuring instrument that measure what? Measure the inductance. It can also measure capacitance and the resistance of passive component or we call them all other electric materials. So we use LCR meter to measure inductance. Say inductance. Yeah. One of the most challenging electrical parameter to measure is inductance. To measure resistance is not difficult. To measure capacitance is not difficult. But to measure inductance, I think that there's a number of research that's still going on because of the complexity in terms of, because you know the inductor, it behaves differently when you supply DC and when you supply AC. Okay? So this is a very huge and very interesting topic. So you say that this one, it can measure inductance, say inductance, capacitance, and resistance. So listen, when you say that it can measure inductance, we used to have inductor. It can measure inductance of the inductor, it can measure capacitance of the capacitor, and also it can measure resistance of the resistor. So resistance of 40 resistor. So listen, but in engineering, in some of the research or some of the areas, we don't have an inductor at the components, or capacitor at the components, or resistor at the components, but we can have inductive property or inductive material. Naomba tusikilizane. Inductor, simply in a simple context, inductor it's electric component. It's a component where its symbol is just like this one. So this is the one with the symbol 40, inductor. Capacitor is also electric component, passive electric component. Resistor is also electric component. So you may use a accelerometer to measure inductance of the inductor, capacitance of the capacitor, resistance of the resistor. But in addition, sometimes we might have some material which describe inductance property or capacitance property or resistance property. And also you can use a accelerometer. Class, is it clear? Kuna inductor kama component na kuna mazingira kutengeneza inductor kwa kutumia property. For instance, if for instance we have two plates. One plate is here and another plate at this point. Then you supply electric energy into these two plates. But there is a space here, right? So if you supply positive, Emmanuel is lumbering, and negative, electric field, right? What do you expect? We expected that this electric field to cross these regions. So the electric field to cross these regions from positive charge to negative charge. Okay? So having this tendency of having a positive plate and negative plate, this is called the capacitive property. It's not the capacitor, but it's capacitive property. This might be maybe one side of the sensor that interfaces with real world, and this is another side of the sensor that gives electric signal. So you may use an accelerometer to measure capacitance of these two materials, but not to measure capacitance of the capacitor, no, of the material that behave as the capacitor. Are we together? Also, there are some materials which behave like a resistor. A good example is an antenna. Any antenna, whether dish antenna or Yagud antenna or monopole antenna or dipole antenna, it acts as a resistor. However, that in most cases, the antennas are just a straight wire, right? But regardless that they are straight wire, they have resistive property. Are we together? Another example is electric iron. Say electric iron. Electric ions convert electric energy into heat energy. So to convert one from electric energy into heat energy means that we need a high resistance material. So one key concept that I want to introduce to you as electric engineers and serious engineers, when you talk about inductance in engineering, we don't mean that inductance of the inductor at the electronics components. We mean that inductance might be inductance of the inductor at the components or at the inductive material. Right? When you talk capacitance, at the capacitance of the capacitor at the electronics components or capacitance of capacitive material. Are you together? When you talk about resistance, we may talk resistance as the resistance of the resistor at the components or resistance as a resistive material. Are we together? Are we together? I want to tell you that all the sensors that we have in the world, they are just using these three principles to detect the real world environment, or phenomena and convert it to electric signal. That's all. But they are not using inductor, capacitor, resistor. No. They are just using the inductance property to detect the real world phenomena and convert into electric form. Are we together? Some of the sensors they use what? Resistive. That's the principle of operation. Resistive. It means that when, for instance, we have one of them is called the light dependent resistor. So this one, light dependent resistor, this is the sensor, right? Where that when for instance, if you supply some amount of light, its resistance decreases. When you expose in darkness, its resistance increases. So when you expose light, resistance decreases. When you expose darkness, resistance increases. But actual is not a resistor, but it's a resistive what? Materials. Are we together, class? Are we together? Well, good. So what are the functions of LCR meter? Simple functions of LCR meter, because we have to discuss briefly. The first function of LCR meter to measure what? Inductance. Inductance of inductor or inductance of inductive material. Of inductive material. Emmanuel is tired today. Also it's used to measure what? Resistance. Resistance of what? Of a resistor or resistive what? Resistive material. Resistive what? Materials. That's the second function of what? Of LCR meter. This is the electric instruments. We are using also in electronics, but not often like in electrical. Then, the third application of LCR meter is used to measure what? To measure capacitance. Capacitance of what? Of a capacitor, whether ceramic capacitor or whether electrolytic capacitor or ceramic capacitor or paper capacitor or air capacitor. And also it can be used to measure the capacitance of what? Capacitive what? Material. So you are familiar with capacitor, inductor, and resistor. What we are adding to you in engineering is just capacitive what? Capacitive materials. Class, say capacitive materials. Say capacitive materials. Yeah. So, types of LCR meter. LCR meter. So, types of LCR meter. So, you have two types of LCR meter. The first one is called the handheld. Handheld LCR meter. I think Johari like it, like the handheld. And the second one is called the bench type. Bench type LCR meter. So you have handheld LCR meter that can carry it, and also you have what? Bench type LCR meter. Are we together? So this is a point to note. We say that the LCR meter is used to test. So this one is used to test whether passive electrical components are working, to test what? Passive electrical components. So it can these are electrical components such as inductor, such as resistor, capacitor, then what? Capacitor, resistor, inductor. But we scared that ensuring what? Their proper functionality. Ensuring their proper what? Functionality. Their proper what? Functionality. Proper functionality in the circuit. So what does it mean? Sometimes you might have separating, sometimes you might have inductor, capacitor, and a resistor. But we are not sure that if that resistor is working or not working, or if that inductor is working or not working, or if that capacitor is working or not working. Because the main function of inductor is to store electric energy in form of magnetic field. The main function of the capacitor is to store electric energy in form of what? Electric field. The main functions of the resistor is actual to limit the flow of current from one point to another point. So the LCR meter can be used to test whether a resistor is working or not working, right? Whether the resistor is alive or dead. Whether the inductor is alive or dead. Whether the capacitor is alive or dead. Okay? Okay, class? Okay. Any question about LCR meter? Then the secondary electric, this is number what? Number 6, yeah? That's what, number 5, number 6. Is clamp meter. How? Okay, so before we discuss about clamp meter, let me ask you, and I ask you to try to answer the question that I'm going to ask you. How are we going to connect the LCR meter in order to measure inductance, capacitance, and the resistance? How? Class operating. How are we going to connect the LCR meter to measure? How are we going to use the LCR meter to measure inductance, capacitance, resistance of the inductor, capacitor, and the resistor? How? Are we going to connect it in series or in parallel, and why? What do you think? Suppose that this is the inductor, and we have terminal A and terminal B. How are you going to measure inductance of this inductor? By using LCR meter. Are you going to connect in series, or are you going to connect where and why? So, Yavan, how do we connect LCR meter to measure inductance of this inductor? In series. Yavan, series, eh? Okay, thank you. The other one, who said parallel? Who said parallel? You are no longer confident. You, parallel. Emmanuel? Parallel. Madam? You don't know. Madam? You don't know. Sure. As what the first presenter said. My brother there with red t-shirt. Parallel. Ostaz? Parallel. Johari? No idea. Parallel. Alice? No idea. Hope? Brother who? Parallel. Brother who? Your name is Parallel. I say brother. I ask your name first. Christian. It measures insulation resistance in terms of mega ohm. That's all. Sawa jamani. Hii si tulishasema ni insulator, si ndio? Unatarajia insulator iwe katika ohm? Yaani kwa akili tu ya kawaida. Yaani upime resistance yako ukute ohm. Si itapitisha. Kama ikiwa kilo ohm itapitisha, kwa sababu nayo kuna resistor nyingi ambazo ziko katika kilo ohm na zinapitisha umeme, ila ni umeme kidogo. Kwa kama endapo ukishika hivi utarushwa. Are we together? Are we together? So the insulation resistance of insulator materials is measured in terms of ohms. Ohms, where we used capital M and the symbol of 40 of ohm. And sometimes several megohms. That's why I call it Ima, how are you? What did I say before I called Ima? Application. So how is it connected to the cable? How megometer is connected to the cable? How is it connected to the cable or device or system? Ask your neighbor. Ima, ask your neighbor. So the ohmmeter is used to ensure, this is used to ensure the safety of electrical system, the safety of electrical system by detecting. So the safety of electrical system by detecting what? By detecting breakdowns. Detecting breakdowns in insulation. Breakdowns in insulation that could lead to shorts. That could lead to shorts or electric hazard. To shorts or electric hazards. So he said that we are using the megohmmeter to ensure safety of electric system by detecting what? Breakdowns in insulation that could lead to electric shorts or electric hazards. What did your neighbor tell you? You are still discussing. Okay, so that's all about the insulation resistance or megohmmeter. But you have to learn how to connect it into the cables, power cables, or electric devices or electric system. Number 8. Number 8 is called the electronics load. Electronics load. Say electronics load. Say electronics load. So I don't know. Si ndio nimeuliza swali, nimekwambia ongea na jirani. Sasa kama mmeshindwa simkatafute. Say electronics load. Emmanuel now is the distance between the upper copper and lower copper of Emmanuel. The distance between the lower copper and the upper copper of Emmanuel's eye previously was negligible. Now it's some few centimeters. Okay, So, who knows electronics load? Have you seen electronics load? It's new, eh? Mmeshai kuona electronics load? Hapana. Haya, tuione basi kwamba ikoje. Electronics load, we say that is electronics device. This is the electronics device that simulate a lot for power supply. For power supplies or circuits. To test their performance. To test their performance under different conditions. Under different conditions. So electronic load, stop writing. This is the electronics device that is used to simulate. Say simulate. Say simulate. A load for power supplies or circuits to test their performance under different conditions. Can I have mobile charger or computer adapter? Stop writing. This is a good example of power supply. Say power supply. The main functions of this mobile adapter is to convert AC into DC. And our domestic power in Tanzania range from 220 volt up to 240 volt. So this one converts that 220 volt up to 240 volt into 5 volt DC. Okay? So this is a power supply from input to output. Hello, Ima? The intentions of this type C mobile charger is to charge the mobile phone. So the load, if for instance, I have this, tashika na chake, hamna shida. So for instance, if I connected this mobile charger into this mobile phone, then this is the power supply. Hello? This is the power supply. This is the load. Are we together? This is the load. But what if this mobile charger has some default and I connect direct to the actual load? It means that the mobile charger will destroy the charging system of this mobile phone. Okay? So instead of that, when these mobile adapters or mobile chargers are made, engineers and technicians, they are using electronic load. Electronic load to test the performance of this mobile charger before connecting the actual load. That's the meaning to simulate. It means that, suppose that this is the electronics load. So if this is the electronics load, we connect this mobile charger into the AC main, and then we connect the outputs into this electronic load. And this electronic load will act as a load, the actual load, in order to study the performance of this mobile charger in different conditions. For instance, if there is a rise up of voltage or rise up of currents, or maybe there's a stepping down of current or stepping down of voltage, what will happen? Because remember that these mobile chargers, they have over current protection and over voltage protection. Are we together? So they using this electronics load as a load, while it's not the actual, not the intended load. So we say that this one will act, or this electronics load will act as a simulation. It means it will be acting as a visual load, but it's not actual load. So you say that is an electronics device that simulates. So simulate is actual, simulation is imitation. Say imitation. Say imitation. So to simulate a load for power supplies or circuits to test the performance under different conditions. So before we sell this mobile charger or mobile adapter to Emmanuel, in industry, production industries, they have to test the performance of this mobile charger. Are we together? So I think that it's clear because this is the new testing instrument. So what are the key parameters? Key parameters. Key parameters of electronics. Key parameters of electronics load. Electronics loads. The first key parameter is voltage. The second key parameter is current. The third key parameter is electric power. Electric power under the load condition. So electric power, voltage, currents, all of them under the voltage. So voltage under the load. The supply voltage under the load. Current under load condition. Electric power under load condition. So here we need load conditions, and this one load conditions. Load condition, and this one under load conditions. So these are the three important key parameters. It means that if you use electronic load to test the power supplies or to test the electronic circuits, our intentions, we want to test the electric voltage, the current, and electric power. Are we together? Yes. Are we together, class? Yes. Then its application. How do we apply it in electrical engineering or in electronics engineering? Application of electronics loads. Applications of electronics loads. So I say that electronics load or electronics load are used to test. Power supply. So these are used to test the power supplies, are used to test the batteries, so used to test the batteries, so used to test the power supplies, are used to test the batteries, and the other power sources, and the other power sources, and other power sources under various load scenario. Load scenarios. So electronics loads are used to test the power supplies, batteries, and other power sources under different TOT or under various TOT load scenarios. Are we together, class? Yes, we are teaching you this because we might expect you that one day you might be working in industry where that the batteries are made or power supplies are made. So that's why that we are teaching you. Class, is it clear? Any question about electronics load? No question. Silent means no question. Number 9. is called the spectrum. Spectrum analyzer. So you have noticed that we are not teaching you anymore about the instruments, the voltmeter, the ammeter, no, ohmmeter, no. We just teach you multimeter. You'll find them. And they've taught you a lot about that. You have to teach you, you have to add value in your knowledge. Class says spectrum analyzer. Say spectrum analyzer. And take your mobile phone. Every student take your mobile phone, whether it's smartphone or iPhone. And then check the recorder application. Just go to the recorder application. Take your mobile phone. The big boss Ima. 2 mobile phones. Then just visit your audio recorder. And then try to record my voice. I want to show you the analysis that we are doing. So once you record the voice, what do you see? Do you see some waves that going up and down? So there are some waves. We call it reverberation, we call it rarefaction and the compression. Do you remember them? Compression and the rarefaction. That is waveform 4. When you have been expert in physics. Nowadays you are veteran, but before you were a teenager. Wonderful, You could cram physics from 1 up to from 4 within a week. But nowadays, cramming even 1 chapter, you need the whole night. And you need to have a backup in the exam. Okay, so that's what we call the audio analyzer. Audio spectrum analyzer. The one that you are seeing is called the audio spectrum analyzer. Are we together? Are we together? So I believe that this is the new measuring instruments, but it's very important even in, we call it in postgraduate studies of electrical engineering. Most electrical engineers, they are using this one in different scenarios. So a spectrum analyzer, a spectrum analyzer is the electronics instrument that is used to analyze what? The electric voltage or electric signal in voltage against the what? Against the frequency. Against the what? Frequency. Yes, against the frequency. So this is the very important instrument that does analysis. Analyze by using the waveform. So it analyzes the electric signal by using the waveform. It means that it's used to analyze. It's used to analyze electric signal, especially by using the parameter that's called the voltage against the what? Frequency. So for that case, we say that voltage in spectrum analyzer, voltage will be presented in y-axis, right? Right? While frequency will be represented in what? X-axis. So this one, it does analysis, but by using waveform. Okay? So it means that if you draw, we examine the spectrum analyzer graph, this will be voltage, and this is frequency. Are we together? Are we together? So voltage against the what? Frequency. While oscilloscope analyze the electric signal or measure the electric signal in terms of voltage against what? Time. Are we together? So the main focus for this instrument is spectrum. Say spectrum. Say spectrum. Say spectrum. Spectrum, whenever we talk about spectrum, we mean light. Spectrum means what? Light. That's why we have 7 what? 7 bands of the light spectrum. Do you remember? Radio wave, the second one. Microwave, the third one. Infrared, the first one. Visible wave, the fifth one, Johari. The fifth one. Ultraviolet light, the sixth one. Gamma rays, number 7. X-rays. Emmanuel, you have forgotten. Once you went to JKT, Roji beef. No, that is color. Roji. Yes, Roji beef. So, radio, This is about color. Okay, so with this spectrum, you might find that the spectrum might be represented in this way, and then you find that something like this. That's what you've seen in that audio recorder software. So the voltage presented will be called sometimes in this spectrum analyzer, the parameter that you're using in voltage is called the amplitude. Say amplitude. Even in oscilloscope you're using amplitude. You have to set the amplitude of the oscilloscope. So this is figure 1, the waveform of spectrum analyzer. Spectrum analyzer. Applications of spectrum analyzer. Applications of voltage of spectrum analyzer. So the spectrum analyzer is used in radio frequency. Radio frequency or RF, and communication system. Communications what? Radio frequency and communication system, or RF and communication system. Content. Communication system for analyzing modulated signal, harmonic distortion, noise. As electrical engineer, because you'll be transferring electric signal, you might be dealing with noises and signal interference. So these are the applications of spectrum analyzer. The first one, operating. The spectrum analyzer is used in radio frequency or RF. Say RF. You are using mobile phones and you are using internet that called the 5G, 4G. Whenever you think about 3G, 4G, 5G, and we are heading to 6G. That's all about radio frequency in telecommunication. Okay? So 5G means 540 gigahertz. We discussed about that in previous class, if you do remember. It means that 5 billions Hz. So in this radio frequency and communication system, what the main function of this one, to analyze what the first application, analyzing what modulated, hello Johari, analyzing modulated signal. Say analyzing modulated signal. Say analyzing modulated signal. When I communicate with my mother in village, when I send the information, or when my mobile phone propagates my information to the nearby base transceiver station, my voice will be modulated with high frequency signal. That's called the 3G, 3 gigahertz or 4 gigahertz. And then also it is analyzing harmonic distortions. Say harmonic distortions. When we talk about harmonics, we discuss like something we discuss in simple harmonic, but here we discuss harmonics in terms of the waves. But we discuss about harmonics in wave. But also it's used to analyze noise. Say noise. Have you ever experienced noise in electrical transmission? Noise. Noise not, no. Electrical noises, right? Because somebody said that noise is just like a human noise. No, no, no. These are electrical noise, unwanted what? Signal. Unwanted electric is being supplied into maybe the AC generator, and you can find that the generator, rather than producing electric currents, it just giving a lot of noise. Okay? Okay? But also it's used to analyze what? Signal interference. Say signal interference. Yes, for instance, this space, there's a number, hundreds of the signals that propagate, being transmitted from south to east, from east to west, from west to east, that's all. So it means that signal may interfere. So spectrum analyzer might be used to analyze the signal what? Interference. Are we together? The last instrument for this lecture is called the voltage tester. That's number 10. Then I leave you to go and read the 10 remaining measuring and testing what? Instruments. So we discuss in class 10, and then I leave a homework for you to go and discuss the other 10 remaining what? Measuring and testing instruments. So after that, we'll be sounding as a good instrumental or instrumentation student. Number 10 is called the voltage tester. Ask your neighbor, what is voltage tester? This is simple. What is voltage tester? Ask your neighbor Johari, what is voltage tester as electrical engineer? Or everything to you is new? Try. What is voltage tester? Is it the electric tester? Ask your neighbor. Voltage tester is electric tester, the one that we use to test the presence of current. First of all, the electric tester, does it test the presence of current or the presence of voltage? So, a voltage tester, keep quiet. A voltage tester is electric testing instrument. Is electric testing instrument that is used. This is simple. That is used to test what? To test or detect. To test or detect what? The presence of what? Of voltage. The presence of what? Of voltage in electric circuit. Electric what? Electric circuits. Ima is still discussing what? Voltage tester. So this one is used to test or detect what? The presence of what class? The presence of what? Presence of voltage. Let me ask you as electric engineers. Do you agree that do you agree with this sentence? Whenever there is a voltage, there is a current. And whenever there is a current, there is a voltage. Is it true or it's not true? Penye voltage pana mkondo wa umeme. Na penye mkondo wa umeme pana voltage. Ni kweli hiyo sentence au si kweli? Kanja hajanielewa. We say that whenever we have a flow of electric current, there is a magnetic field. And whenever we have a magnet, there is a electric current. Right? So now I want to ask you about current and the voltage. Those are contradicting parameters in electric engineering. Do you agree with the sentence that whenever we have voltage, there is a current? And whenever we have current, there's a voltage? Kanje bado hajaelewa. Kanje, nitumie mfano gani? Tunasema hivi, unakubaliana na sentence ima. Unakubaliana na sentence kwamba penye voltage pana mkondo wa umeme, kwa sababu current kwa Kiswahili japo umesahau ni mkondo wa umeme. What itaita current? Kwa sababu sasa hivi ushakuwa mswanglish. Yaani wewe sio pure Swahilist. Uvojua tu Kiingereza kidogo, umekuwa tishio wa Kiswanglish. Unajua current ile pale. Utaki kuumia tena kukumbuka current ni nini? Current ni mkondo wa nini? Kwa hiyo penye mkondo wa umeme pana voltage. Na penye voltage pana mkondo wa umeme. Ni kweli hiyo sentence au si kweli? Kweli. Wengine wanasema kweli. Wewe madam unasemaje? Watakao sema wao kasema. Wengine wanasema kweli, wengine sio kweli. Himo unasemaje? Kweli. Kweli? Kweli? Kwamba kila kwenye voltage kuna? Nawaachia hii. So this one is actually detecting the presence of 40 voltage, right? Presence of 40? Presence of 40? The common type of, keep quiet, voltage tester. The common type of voltage tester is called the non-contact voltage tester. Non-contact voltage tester. Say non-contact voltage tester. Say non-contact voltage tester. Non-contact voltage tester. Non-contact voltage what? Tester. My friend here is replying a triangle message. Where are you, father? I'm on the way. Where are you? Now I'm at Ubungo while you're at DIT. Okay, so we say that. So the non-contact voltage tester. The non-contact voltage tester is electrical testing instrument. That's why the topic is called the electronics measuring and testing instruments. Are we together? Some of the instruments are not measuring, just test. Okay? However, that most of them they are performing the activity of 40 measuring, but some of them are used for 40 testing. Right? Right, class? Yes. So the non-contact voltage tester is electric device that is used to detect what? To detect the presence of what? The presence of Ima, you are no longer writing. The presence of what? Of voltage in electric circuit. Ima say that I'll write later. You don't have later. Electrical circuit. Without the physical contact. Physical contact with the circuit. So this is a voltage tester. We say that, listen, suppose that, how does this work? This is the conductor, suppose, or a cable, carrying current or voltage from point A to point B. Separating. It is insulated the cable. It is insulated what? Cable. In order to measure voltage, hello Alice. In order to measure voltage, always we need to connect a voltmeter across the 2 points. Hello brother. It is enough. Postpone it for a while. I'll give you time. Okay? Let us finish the class, then you will enjoy it. So, whenever we want to measure the voltage across 2 points, we need the 2 tips of the voltmeter to be connected to the conductor. Are you together? But with this voltage tester, this is insulated cable. Okay? This is insulated what? Cable. You are not, I mean that the voltage tester, when you bring, or when you take the voltage tester closer to this cable, then it will detect the voltage test. It will detect the voltage. If it is digital voltage tester, it gives you the actual measurement. If it's just to test it, it can give you an alarm, a beep. So whenever you hear a beep, there's a voltage. If there is no beep, there's no voltage. Are we together? So it means that if this is the conductor that carrying voltage from one point to another point, hello madam, this is the voltage tester. My chalk is the voltage tester, right? So with this non-contact voltage tester, the voltage tester is not supposed to be in contact with the wire or with the cable. The voltage tester is just wanted to is supposed to be closer to the cable in order to test the presence of voltage. If that's the case, what the principle applied by the voltage tester to detect the voltage? Did you hear my question? We say that, according to this sentence, we say the non-contact voltage tester is an electric device that uses to detect what? The presence of voltage in electric circuit without physical contact with what? With the circuit. Suppose that this is the cable. Hello? Carrying voltage from point A to point B. Okay? This is our voltage tester. How are you going to test the presence of voltage? Simple. You just have to bring closer and closer this voltage tester up the certain distance. Then it will sense without physical contact with the conductor. Remember, this physical or this cable, it's insulated. Okay? But remember that magnetic field and electric field are not cannot be administered, are not limited with insulator materials. They can penetrate. Okay? So this voltage tester will use the principle of what? Induce the magnetic field. Why? Because this is the cable. Then because the cable carrying the voltage from point A to point B, there is a grippings, or we call this magnetic fields. So if this voltage tester is subjected to the magnetic field, strong magnetic field, then that magnetic field will be sensed by this voltage tester, and then will be defined in such a way that produce an alarm. There's a voltage flowing from point A to point B. That's all. So we have two types. We have 2 kinds of the non-contact voltage tester. One, you can find a digital voltage tester that have a display to display the amounts of voltage. And also the other ones, it doesn't have the display. It's just as an alarm. It means that it contains a buzzer, right? So when you hear the sound, it means there's a voltage. When you don't hear any beep, it means there's no voltage. Are we together? Yes. And that is more our students in departments of electronics and telecommunication, they used to make, or they always make that voltage tester at the year final year project for ordinary diploma. And it is real working. I saw it. Class, is it clear? Yes. Is it clear? Is it clear? Okay, finally, application of this voltage tester. Used it for checking if the power lines is live, or for testing the presence of voltage in the circuit. So a voltage tester is used to distinguish, let's say, distinguish a live wire from neutral wire in OT, in power, or in electric cables, or power lines. Live wires always carry power from the source to the load. Neutral wire return small amount. So the voltage tester will sense the voltage presence in the live wire rather than neutral wire, because neutral wire has a weak magnetic field. Class, are we together? Is the concept clear? Did you understand? Questions? Questions? Are you sure? Pardon? DC supply. How voltage tester may be used to test the DC supply. Yes, it can be used, because in case of DC supply, this is one of the applications. For the DC supply, we just have a positive wire and negative wire. So replace the live wire with positive wire that carrying DC current from the source to the load, and neutral wire replace with negative wire that actually carrying current from the load, small amounts of current or voltage from the load towards the source to complete the loop. Are we together? So the voltage tester is not limited for AC only. No, it can be used for DC system. As long as you have magnetic field. Remember that magnetic field are generated in DC power source and AC power source. Are we together? Are we together? Yes. Wow. So if that's the case, this is the end of lecture 2. I would like to invite you in lecture 3, where actually that will be discussing in detail about multimeter and how to use it, just the measuring instruments, and then we go for the practical to do the measurements by using the digital multimeter. So class, is the concept clear? So it's time to relax. It's time to relax. For those who like to relax. So it's time to relax, to congratulate yourself. We've been doing a great job. So it's a time for us to congratulate ourselves. 1, 2, 3. Ongereni. Imareni. Wow. Again in English. Good. Better. Best. So I know when our kids now will be singing the songs in kindergarten schools, you will understand.
Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki